We make inferences concerning the future on the basis of what we know about the past. How can such inferences be justified? They could be justified, it seems, only if it can be assumed that the future resembles the past. But it is only by way of such inferences that we can know anything about the future, so we cannot legitimately make such an assumption. How is this vicious circle to be broken? This is the problem of induction. The solution to the problem of induction lies in the following simple truth. Explanation is discontinuity elimination. To explain is to eliminate discontinuities. It is to get rid of gaps. In my book, The Problem of Induction, it is explained why this is true and why a consequence of this truth is that there is no problem of induction. In the following promotional excerpt from the audio version of this book, expertly narrated by Adam Zenz, some of the key points of the argument are stated. Please enjoy the following promotional excerpt from my audiobook, The Problem of Induction, professionally narrated by Adam Zenz, and available at audible.com.
Discontinuity-elimination, the essence of explanation. If correct, a given IBE is a case of anomaly-elimination, supposing that D1 ... are the empirical data at our disposal. H is a good IBE to the extent that H fills in the gaps left by D1 ... Dn. Question. What if D1 ... Dn are such that any hypothesis H that fills in the gaps left by them is inevitably false? What if D1 ... Dn is such a limited or otherwise imperfect dataset that if a hypothesis does a good job of modeling that particular dataset, it stands no chance of being true? Answer. This happens, but we have to work with the data we have, not the data we want. The data we have, what our eyes, ears, etc. have told us, the data we want, the data that, if appropriately modeled, apprises us of the structure of the world. Question. How do we deal with this fact? Answer. By acquiring more data. False hypotheses may do a good job of modeling limited data sets, but precisely because they're false, they tend not to model enlargements of such sets. False hypotheses don't travel well. A lie may work in a particular context. You lie to your roommate about eating his powdered donuts, but as data comes in, it becomes increasingly difficult to compatibilize the lie with the facts. He turns on the light and sees donut powder on your face, the donut jelly on your fingertips, etc. The jig is up. Question. Given some relatively large and comprehensive data set, D1 ... Dn, some data set that is sufficiently large that false hypotheses are unlikely to model it, what is to fill in the gaps, quote, in that data set? Answer. To eliminate anomalies is to eliminate discontinuities. To explain an event E** is to identify some E that is the cause of E**. E is the cause of E** if, given E**'s occurrence is not discontinuous with the state of the universe prior to E** occurrence. Example. You see a red ball roll into an opaque, non-see-through tunnel. A moment later you see a red ball that is otherwise the same as the first ball roll out of the other end of the tunnel. Hence your data set. D1. Red ball rolls into one end of tunnel located at place P at time t. D2. Red ball rolls out of other end of tunnel located at place P**, 10 feet away from P at time t**, 10 seconds after t. D3. What you saw or otherwise perceived during the spatiotemporal interval defined by the distance between P/T and P*/T* is in no observable way continuous with the sudden emergence at P*/T* of a red ball. Hypothesis H. The ball that rolled into the tunnel is identical with the ball that rolled out of the tunnel, and while the ball was in the tunnel, it continued to roll, that being why it was able to exit the tunnel even though it was not observed to roll. If the totality of the facts were as D1/D3 described them, the emergence of a red ball from the tunnel's end would be an instance of ex nihilo creation, an event that had no roots in the state of the universe prior to its occurrence. Given both D1/D3 and H, the balls exiting the tunnel is appropriately continuous with the state of the universe prior to its occurrence. The reason is that, given D1/D3 plus H, the balls emerging at T* from the tunnel is a part of a continuous process. Continuity equals causality. Explanation equals continuity-restoration. Given a data set D1 ... to model that data set is to posit something X such that given by D1/D3 plus X, the facts described by D1 ... dn are fragments of structures/processes that don't comprise discontinuities.